Hey, power people. Welcome to Renewable Rides. I'm Gareth Evans.
And I'm Dan Roberts. We're the founding team of VECKTA, a platform and marketplace streamlining how companies buy on-site energy.
In each episode, we'll uncover the latest trends, challenges, and triumphs relating to the energy transition through the experiences of our team and our inspiring guests.
Our goal is to help companies take action to create a resilient, profitable, sustainable, and thriving energy future.
Let's go.
Hey everyone, and welcome back to another episode of Renewable Rides. And Dan and I are honored today to be joined by Arun, who is the founder and CEO of Skyven Technologies. Arun, we are very excited to have you on because we often hear a lot of our customers talking about industrial energy pain points and not having a clue what heat pumps are and wanting to learn more. So excited for you to educate us today.
Well, thank you so much for having me on. I appreciate the opportunity.
So Arun, we always start off with what are you passionate about?
Yeah, well, as you might imagine, I'm very passionate about climate change and fighting it, and in particular, industrial process heat. Industrial process heat accounts for about as much carbon as all of transportation. So that's all the cars, trains, planes, boats, everything combined. It has received 100, maybe 1,000 times less attention and less investment than clean transportation. But it is every bit as important in the puzzle of solving climate change. And so I'm quite passionate about making a difference in that space.
It's great. Yeah, you're absolutely right. It gets very little attention, but a huge problem to solve and arguably more difficult to abate. So, Arun, how'd you get here? What have you been doing prior to founding Skyven, and what drove you to create the company?
Yeah, well, thanks for asking. This was 10 years ago. So I started Skyven 11 years ago in 2013. It's been a while. And so I started Skyven long before industrial heat was a hot topic, so to speak. I mean, back then, no one was thinking about it. The Department of Energy wasn't even thinking about it. The Department of Energy was saying, like, we do solar here. But really, I actually got started as a technology looking for a problem, so to speak, because my background is in engineering. And so I had, I was previously working for a company called Texas Instruments, for a business unit called Digital Light Projection, DLP. And DLP makes these microchips that have millions of microscopic mirrors embedded on the surface of the chip. I'm not at my desk at home right now, although I actually have one sitting at my desk. These chips power almost every cinema projector in the world. So if you watch a movie in the movie theater, you're watching it on a chip that I designed or was a lead designer on. The chip, the microscopic mirrors on the chip physically move, and each one represents one pixel on the screen. And so by moving, it creates a moving picture, a movie. And so I had a lot of expertise in manipulating light, and thought I could use that expertise to manipulate a different light source. Instead of a projector bulb, could manipulate a bigger light source, the sun, in order to concentrate sunlight and capture the heat in the sun's energy. And so Skyven was originally founded around an innovation in concentrating solar thermal. And so that was the technology. And the problem that we found was industrial heat. At the time, there was a clean tech boom was sort of fading away, and there were a lot of entrepreneurs, very talented entrepreneurs, that had started solar companies and were struggling. And I talked to many of them, and they said, "Hey, solar is really tough." And so then I asked, "What about industrial heat?" And they were like, "Industrial heat? So what is that? We have no idea. Like, no one's looked at industrial heat. We don't know anyone who's even considered it." maybe there's a market there, maybe there isn't, we don't know. And so I was like, well, that sounds like a white space, that's interesting. Let's go look at that. And that's how I got into the space in general. But as we got deeper into it, my team and I, we really fell in love with the problem. And in doing so, we discovered that solar thermal is not a great solution to the problem. The problem is manufacturers need a huge amount of heat in order to process everything that they make on a daily basis, whether it's the food we eat or the clothes we wear. It's things like pasteurizing milk, you heat milk to pasteurize it, or baking bread, or heating chemicals so that they react with each other, right? It's very, very broad different processes, but they all need heat. And that heat today is being supplied by burning fossil fuels, right? So we're burning fossilized dinosaurs to create heat to manufacture stuff. And I thought the solution was kind of like this big burning ball of fire in the sky. But what we found was that it's just the sun doesn't provide enough heat per square meter of space on the ground in order to really provide the heat that these manufacturers need, because they need so much heat. You would just need an obscenely wide field, like a very large amount of space. So meanwhile, while I was visiting manufacturers and talking to folks in manufacturing facilities, we found that there are other technologies out there, like efficiency technologies, for example, that are pretty amazing. They would actually save more energy than the solar thermal technology that we were peddling at the time, and they cost less. So there's a win on both ends. And I was like, wait a minute, what am I doing here? Well, why am I trying to sell this solar technology when there's already stuff out there that's better? But more importantly, why is that not being adopted? And that's when we made essentially a hard pivot away from solar thermal to energy efficiency as a service, with the goal of helping manufacturers make their facilities more efficient by helping them adopt the technologies that they have at their disposal today. And then, while exploring that at length, we found that many manufacturers have sort of already deployed a lot of the efficiency technologies that are available to them, like the leading ones, and the ones that are not deploying them, they're really struggling with just a priority, and they're struggling to make that a priority. And but fundamentally, the reason the priority issue was because these efficiency plays can save maybe 10-20% of their fossil fuel consumption, but they're not really going to do better than that. And in order to make it worth their time, manufacturers needed a bigger bite at the apple, needed to save more energy and more carbon, for a single effort. And that's what ultimately led us to what we're pioneering today, and that is a large-scale steam-generating heat pump that allows manufacturers to cut their carbon emissions by 50 to 80%.
Wow.
In a single project. And we offer that as a service, so manufacturers don't have to put up the capital to pay for a system like that.
Super interesting. We often heard, we think the energy efficiency industry was a lot more mature than it is, Arun, and that everyone had kind of deployed all these systems, and that's where on-site energy would come in and help them, now offset their emission profile. what we've come to learn through speaking to a lot of our customers is either one, they haven't even started the journey, or two, they've kind of picked off the low-hanging fruit, things like LED lights and things like that. What is the biggest barrier for businesses when they think about heat pumps today? Is it a lack of awareness? Is it not understanding the financials? What are you seeing in the market in terms of that barrier?
Yeah, no, it's a really big and important question here. I think that the biggest barrier first is that bandwidth issue, is finding the priority to go after these opportunities. And so, manufacturers after decades and decades of cost cutting are all running real lean staffs, and they just don't have a lot of extra people to go and implement energy efficiency measures. So that's probably the biggest challenge. I think awareness is another big challenge, and then the possibility for facility downtime is another huge challenge. In manufacturing, because they're running such thin margins, the factory has to remain up all the time. Their downtime costs are extremely high. I'm talking like $50,000 an hour of cost. And so if you implement an efficiency measure that saves you $200,000 a year, it seems like a lot of money, right? Like that's a whole person's salary, maybe two people. But just 4 hours of downtime kind of eats your savings up. And that's a big challenge as well. So the reliability and uptime requirements, and not causing, also if the manufacturer is trying to implement an efficiency measure that involves changing their process in some way, reducing temperatures and that kind of thing, and it affects the quality of their product, affects their ability to sell that product, that's also a non-starter. So like these are like some like body of issues. I wish it were just one, but it's kind of all of them.
So what is the 101 on heat pumps for, many of us hear the term, but we often don't even know what it is. Before we get into kind of your specific solution, what's just the general theme and strategy behind it?
Yeah, a heat pump, rather than so it's kind of easier to start with like what we all know, like we all understand a flame, right? You're burning something to produce heat. And so it's a chemical reaction of the fuel to release that energy in the fuel and generate heat. Heat pumps are fundamentally different. They are not consuming a fuel to generate heat. Rather, they are moving heat from a cold, cooler area to a hotter area. They're essentially taking low temperature heat and concentrating or upgrading the temperature of it in order to generate higher temperatures. So in a house, like for example, if you have a heat pump at your house, generally what that's doing is taking cooler temperatures from outside and upgrading the temperature of that heat from outside to heat your home inside, to generate hotter temperatures inside. And the air conditioning works in reverse. It is taking heat from inside your house and upgrading it and dumping it outside. And so industrial heat pumps work very much the same way. They're taking low temperature heat from somewhere and upgrading it to use somewhere. And in industry, what's really incredible about industry for heat pumps is that industry has a large amount of low-grade waste heat. That is low temperature heat that's not hot enough to do anything without the plant. And so they actually have to reject it, and they have to pay money and install equipment for things like cooling towers in order to get rid of the heat, because they can't do anything with it. I got to get rid of it. I got to dump it into the atmosphere. And so the opportunity for a heat pump is to take that heat, upgrade the temperature to make it hot enough to actually use it back inside the plant. So heat pumps are really a form of heat recycling or upcycling, or taking what is typically dumped into the atmosphere, grabbing it, upgrading it, and then reusing it.
Excellent explanation. I have a heat pump in my house, so I've thought through that quite a bit, but I think it's easy to understand the way you described it. Well, so you mentioned a couple different examples in one of your descriptions earlier. You mentioned pasteurization of milk. You mentioned bakery and baking goods, manufacturing processes, chemicals. Walk us through some specific examples, maybe where your technology has been deployed. What were they doing before? Boilers, I assume, and then what are they experiencing now, both from an emissions and potentially a cost reduction?
Yeah, so just to provide a little overview on what the technology is today, and we talk about some of the applications where it's been used. So the technology, it's the Skyven Arcturus steam generating heat pump, and it is a heat pump that is an external retrofit in the plant, and it takes waste heat, like we were just talking about, as low at temperatures as low as 85 Fahrenheit, and then upgrades the temperature to temperatures as high as 420 Fahrenheit to generate steam to use in the facility for things like pasteurization or drying and that kind of stuff. So then the applications for use depend on the industry. So for example, in the ethanol industry, where an ethanol manufacturer is basically brewing beer, distilling that beer to separate the alcohol from that beer, and then that alcohol is being used generally for fuel purposes. In order to separate out alcohol from beer, you got to boil the beer, because alcohol boils at a lower temperature than water, and that allows the separation. And so the way a plant works today, that beer is boiled, the ethanol comes out, and then it's ethanol vapor. It needs to be condensed back into liquid ethanol. And the process of condensing requires, just like if you have a dehumidifier, it's like there's like a cold coil in your dehumidifier, and it's like cooling the air, and that's how it gets the water out. This is the same thing. That's how a condenser works. You actually have to cool the vapor to turn it back into liquid. And so that requires a tremendous amount of heat, low temperature heat. So it's cooling, it's low temperature heat to get rejected, and it gets rejected to the atmosphere. And so as the heat pump takes that low temperature heat that is being extracted from the ethanol vapor, upgrades it back to steam so that it can be used to boil more beer, instead of having to burn fossil fuels to produce steam to boil the beer.
So you're just constantly upcycling the wasted heat. And so in the process, you're essentially electrifying the heat process, correct, Arun?
That's right.
Yeah.
That's right. So it electrifies the heat process, turns the heat into a circular process where the heat is used, recycled, and then reused and recycled. So it just keeps on getting used over and over again. And we use electricity to upgrade the temperature from low temperature to high temperature to kind of close the loop, that recycling loop.
Okay. And then with natural gas being relatively like affordable today, who knows where it'll go to? Why does electrification of your heat generation make sense financially for you as a business leader and owner today?
Yeah, so the beauty of a heat pump is that it is not consuming fuel to generate heat. It's just moving heat that's already there. And so in doing so, it can be far more efficient than a traditional boiler. So a natural gas boiler is burning natural gas. The combustion and process is never 100% efficient. So you're generally talking about 83% efficiency to burn natural gas to produce steam, whereas a Skyven Arcturus steam generating heat pump is able to use electricity to move and upgrade heat. And so the electricity consumption versus the amount of steam you get out for every unit of electricity you put in, you get 3 units of steam out. Whereas again, with natural gas boilers, for every 1 unit of natural gas going in, you get 0.83, 83%, 0.83 units of steam going out. So you're talking generally about 3 times higher efficiency per unit of energy. And so that means that even though electricity is generally more expensive than natural gas is super cheap, because the system uses such a small amount of electricity per unit of steam generated, it's actually able to compete and oftentimes beat natural gas on price.
That's great. Well, what sorts of applications are you seeing the biggest traction within?
Yeah, in general, the industries that are the best fit are industries that consume huge amounts of steam. Those are pulp and paper, chemicals manufacturing, and large food and beverage. And so, for example, in pulp and paper, it's steam used for paper drying. In chemicals, it's typically used for separation, like the ethanol example that I just talked about. And then in food and beverage, it's either used for baking or cooking or evaporation.
And what are there's obviously lots of different heat pumps out there, Arun. Like, what's unique about your approach versus other products in the market?
Yeah, thanks for asking. So the Skyven Arcturus steam generating heat pump has the lowest energy consumption per unit of steam generated of any technology, whether it's a heat pump or a boiler or anything else, period. So any technology out there, that's a hard, cold statement. There's no caveats. And so that's the big advantage of the Arcturus steam generating heat pump. Now, compared to, like, the question I often get is how is that possible? What do you do different to get the best? So generally, heat pumps are better than other technologies, and the reason why we're the best heat pump is because we use a fundamentally different architecture than other heat pumps. We utilize an architecture known as mechanical vapor recompression, which is a technical term that basically means steam compression. So our refrigerant in our heat pump is water. And the way we use water to be a refrigerant in a heat pump is extremely thermodynamically efficient. That's how we're able to be the best. But it only works at large scales. So it really can only work at industrial scales. This system doesn't scale down. I would love to put one of these things at my house, but it just doesn't. We can't scale it down that small. And so that's why it's kind of a unique technology that is unique to steam generating heat pumps.
Love that. The other thing that you've mentioned early on, and the other piece that you brought to the table is a business model innovation. So you've got the technology innovation that you just described, but then you've got the business model innovation. So maybe talk our listeners how you remove other barriers to folks adopting this.
Yeah. Well, so we found that there's a technology issue, like we've talked about, and the need for, like, hey, we need a way to decarbonize our operations that's financially attractive, but the capital is often a barrier for manufacturing facilities. Every manufacturing facility I've ever visited has a capital budget, and they always have more projects than they have money for, whether it's a facility owned and operated by a wealthy company or by a company that's just scraping by. It doesn't matter. The facility has a budget, and they got more uses for the money than they got money. And so one of the things that Skyven is doing is providing this heat pump on an energy as a service contract, where Skyven covers all of the capital expenses. so the customer doesn't have to come up with any capital. And then we use meters to measure how much steam the system is actually producing, and we meter how much electricity it's consumed. And then we calculate with real measured data how much the system, how much it's saving, how much natural gas is a system saving, and what is it costing due to electricity. And then we share the savings with the customer, and that's how we earn a return on our investment. And so this sort of model has a benefit of aligning our incentives with our customers' incentives. We can't make any money unless the customer is saving money. So we're very incentivized to make sure that the project is working and saving the customer money, because that's how we make money. And then it solves the customer issue in that they're able to preserve their capital budgets for projects that are more core to their core business of making yogurt or whatever it is they manufacture.
And Arun, if I decided I wanted to do this today for my business, what's the lead and planning time that I need to be thinking about before the system is operational and I'm getting those savings?
Yeah, good question. So this is a large capital project, and so like other capital projects, it requires a careful engineering and equipment procurement process. Skyven manages all of that from the engineering, from the very concept all the way through full construction and operation. So we take that burden off the customer, and also, in addition to the capital budget, it kind of frees up their bandwidth as well. We take on a lot of the heavy lifting. It does take time though. So generally you're talking about 2 years between being ready to go and actually having a system operational.
Yeah, okay. So what would so if I'm a business leader listening to this, what would be the advice and the messages you would want to leave ringing in their minds when they're thinking about costs, inflation, decarbonization, all the above? Like, what do you want to leave people with?
Yeah, it's a good question. So I would say Skyven Arcturus heat pump allows you to decarbonize your operations and save money and increase the reliability of your steam supply, and do all of those things without any capital costs in a model that aligns our incentives with yours, and so that we make money when you save money.
Sign me up. Well, what is the one thing that is kind of maybe, if anything, that's slows down adoption that you see companies running into, whether it's just getting higher up approval or capital allocation committees signing off on it, ops teams feeling like this will disrupt operations? Like what are some things that as a business leader I should be thinking through that might get in the way of us adopting this, that I can start laying the groundwork now for?
I think the biggest challenge from that perspective is that there are many stakeholders inside a customer organization. And those stakeholders will include operations, like you mentioned, certainly include finance, includes legal, includes the engineering team. And like the thing that helps the most is having someone within the organization that really champions the idea and says, like, okay, I'm going to get to the bottom of all of the questions and make sure that everybody's concerns are addressed, and everybody's comfortable moving forward. Because otherwise, without that, all of those different stakeholders are going to have really valid, really important concerns that are all addressable, but they need to be laid out there and then discussed, and then solutions, are found. That's the process. But it takes a shepherd to kind of guide everyone through the process. And that shepherd is probably the biggest difference maker. Organizations that have that shepherd are able to to realize all the benefits that we talked about. Whereas organizations that don't have that shepherd may kind of get jammed up in the process and rigmarole of it all.
Yeah, I love it. I think the key here, isn't it, is thinking beyond the next month, the next quarter. This is like long-term compounding value that really kind of sets you up for long-term success versus, just making these knee-jerk reactions to changing environments around you. Like, let's get ahead of it and proactively address the market and the opportunity. Arun, to close us out, would love for you to finish this statement for you from a personal or a professional context with respect to the energy transition. But I will have been successful in my life when?
Oh. I will have been successful in my life when I got to put family first. When my kids are grown and happy, and then I'm going to put professional second. And that is, when we have made steam generating heat pumps industry best practice, and where they're actively displacing the burning of fossil fuels across industry.
Great way to end. Really appreciate your time, Arun. I think a very exciting portion of the market, huge opportunity for businesses to really truly stand out and differentiate themselves and optimize their operations. And so thanks for taking the time talking us through it today.
Yeah, again, thank you for the opportunity. Really, really appreciate it. Love what y'all are doing at VECKTA.
Cheers. Well, Dan, you a heat pump fan? What are your reflections?
Yeah, well, I mentioned I've got one in my house, and that was frankly, after a carbon monoxide scare. So that's a good reason for individuals to be thinking about these types of technologies. Obviously, a little different in the industrial sense, but the thing that I really took away was the similarities between electrification of industrial processes. So going from natural gas fired thermal sources or thermal loads, in this case steam, but there are many other thermal loads within industrial processes that can be electrified, and on-site generation and storage. There's so many benefits between certainly financial, as Arun hit on, decarbonization, quality. He mentioned the quality of the heat being that much better, and similar in on-site generation and storage being the resilient component of it. But needing to make sure that these are big investment decisions, and needing to get all of the different stakeholders across operations, procurement, finance, C-levels, and all the way up to the board in some cases, all kind of rowing in the same direction and heading down this transition journey, and having that, as you mentioned, that longer term view, and investing in assets. I think that we need to have business leaders thinking longer term, and I hope that highlighting technologies like Skyven will drive the adoption of more of these. How about yourself?
Yeah, I really like the efficiency play. I can either burn a bunch of gas and get an 80% return on my investment and it's kind of gone, or I can install a heat pump and get a 3-to-1x on my investment, and it's a upcycled system, so I'm constantly optimizing how I operate my business, and so it's not this one and done loss. It's a compounding value creation. I really like that, and I think that really sets up that future investment. I love how they've removed the barrier to entry from a capital perspective. I think that heat as a service is really nice, and it supplements the energy as a service contracts that we see. I think the reality is for businesses moving forwards is they can genuinely remove any capital expenditures and lock in and hedge their operating costs, and especially in an environment that is very inflationary and isn't going away anytime soon. I think a lot more business leaders are going to pay attention to those kind of inflationary hedges, and I think that's super exciting. And I think it just highlights for us that as more and more assets electrify, on-site generation storage is just going to become increasingly important, because we don't want to be at the mercy of, we've just electrified our facility and we're super stoked about it, and then the utility jacks up all our prices and we're no further ahead. So how do we take control of our operations in their entirety? I think it's very exciting times.
Yep. Own your power.
Yeah. Love it. Well, happy birthday. Have an awesome
Thank
day.
you.
Good
Like that.
episode.
Yeah. Appreciate it. Appreciate it. Look forward to the next episode.
Right, catch it.
We receive a lot of questions from business leaders around the world wanting to learn more about the energy transition, what is possible, and where to start. So to help you stay informed and up to date on best practices, opportunities, risks, and success stories, we created an industry newsfeed at VECKTA.com/news with all our podcasts, blogs, and newsletter. Check it out and connect with Dan, myself, and the VECKTA team to learn more. Cheers and have a good one.